Hey, eighth grade. Okay, this is the new lesson for today, slopes of parallel and perpendicular lines. Okay, we are at page 349. Now, let's define parallel lines. Two different non-vertical lines are parallel if and only if they have the same slope. Okay, all different vertical lines are parallel. So here we have two examples. Notice this example. We have the graph of two lines. Okay, they are both written in a slope-intercept form, y equals mx plus b. And notice that for both, the slope for this line and the slope for this line are equal. Remember, in a slope-intercept form, y equal mx plus b. So, what is the value of m of this first line? M equals 1x, and for this one, m equals 1x. So notice that m equals 1 here, m equals 1 here. Since m1 equals m2, right, we know that y equals x plus 2 is parallel to y equals x minus 3. They're parallel because their slopes are equal. Now, in the second case, we have two vertical lines. By definition, all different vertical lines are parallel. Look, x equals negative 3, x equals 4. Notice that in this case, if we write them in a slope-intercept form, the slope is undefined. That's why we have vertical lines. So two different vertical lines are parallel. So we can state that x equals negative 3 is parallel to x equals 4. Why? Because the slopes for these two lines are undefined. So if we look at example 1, it says identify which lines are parallel. And we have 4 lines in here. We have y equals 4/3 x plus 3, y equals 2, y equals 4/3 x minus 5, and y equals 3. Okay, so we have four lines. Okay, 4 linear equations. Now, we have to identify which lines are parallel. Okay, now if we look at y equals 2 and y equals negative 3, okay, we know that we're talking about two horizontal lines. Y equals 2 and y equals negative 3. If we write this in a slope-intercept form, we get y equals 0x plus 2 and y equals 0x minus 3. Yes, in a slope-intercept form. That means that for this case, m1, I'm going to call that m1 equals 0, and m2 equals 0. Yes, m1 equals m2. Since they are equal, then we can state that y equals 2 is parallel to y equals negative 3. Why? Because their slopes are equal. Now, let's look at the other two lines. The other two linear equations. We have y equals 4/3 x plus 3 and y equals 4/3 x minus 5. Okay, notice in this case m1 equals, what is the value of m? 4/3, and the value of m2, the slope, 4/3. Okay, so here we can state that m1 equals m2. They're both 4/3. So we can say now that y equals 4/3 x plus 3 is parallel to y equals 4/3 x minus 5. Okay, so here we have the graph of the four lines that we were talking about, and notice this line, y equals 4/3 x plus 3, and y equals 4/3 x minus 5. If we analyze them, we'll see that these two lines will never intersect. Okay, and by looking at the equations, we know that they have the same slope, so we say that these two lines are parallel, and these two lines are horizontal lines, which means that their slopes are equal to 0. So they both have the same slope, 0. So we can say that y equals 2 is parallel to y equals -3. Now, part B, we have y equals 3x plus 2, y equals -1x plus 4, x plus 2y equals -4, y minus 5 equals 3 times x minus 1. So notice that here the first two equations are written in a slope-intercept form. The third linear equation is written in a standard form, and the last one is written in point-slope form. So the best way to do this is to write them all in a slope-intercept form. Okay, remember the slope-intercept form is y equals mx plus b. Let's write all of them, all of those linear equations, in the form y equals mx plus b. So the first equation, y equals 3x plus 2, it's already in a slope-intercept form. The second equation, y equals -1/2 x plus 4, it's also in slope-intercept form. The third equation, x plus 2y equals -4. How do we write this in a slope-intercept form? Okay, let's solve this equation for y. So let's leave y by itself. X, we move it to the other side of the equal sign. Now we have 2y equals -x minus 4. Why negative? Here at this side x was positive, so whenever you move anything to the other side of the equal sign, you do the opposite. The opposite of positive x is -x. Okay, now we have to leave y by itself. So here we're multiplying by 2. So to leave y by itself, we have to divide by 2. So we get y equals -1/2 x, -4/2. Okay, so we can simplify that. Y equals -1/2 x minus 4 divided by 2, 2. And the last equation, y minus 5 equals 3 times x minus 1. Okay, we're going to write it in a slope-intercept form. First thing is to do distributive property here. So we get y minus 5 equals 3 times x minus 3 times 1, 3. Now we move negative 5 to the other side of the equation. So now we get y equals 3x minus 3. Okay, here we have negative 5, so if we move to the other side of the equation, it will be positive 5. Now we simplify. Y equals 3x, negative 3 plus 5, that's positive 2. Now we have all of our linear equation in a slope-intercept form. So let's identify which ones have same slopes. So for this one, for the first equation, the slope m is equal to 3. Equation number 2, m equals negative 1/2. Equation number 3, m equals negative 1/2. And equation 4, m equals 3. So now, let's identify which one have the same slopes. So equation 2 and equation 3 have the same slopes, 2 and 3. Okay, 2 and 3 have the same slope, negative 1/2 and negative 1/2. So we can state that y equals negative 1/2 x plus 4. Okay. Okay, so to make this easier, I'm going to call this m1, m2, m3, and m4. Okay. So here we can state that m2 is equal to m3. m2 equals to m3. And since that is true, so we can state that y equals negative 1/2 plus 4 is parallel to x plus 2y equals negative 4. Okay? Now notice that slope 1 is equal to slope 4. Slope 1 equals 3, slope 4 equals 3. So we can state that m1 equals m4. So y equals 3x plus 2 is parallel to y minus 5 and equals 3 times x minus 1. Sorry guys. Y minus 5 equals 3 times x minus 1. Okay? And that's how we do example 1.